evidence mounts for the existence of the universe's largest stars. Astronomers, using the James Webb Space Telescope, JWST, have found compelling, though not definitive, evidence for the existence of supermassive stars in the early universe, stars far larger than any observed today. These potential behemoths, estimated to be between 1,000 and 10,000 times the mass of our Sun, could rewrite our understanding of how the first galaxies formed and how supermassive black holes came into existence so rapidly. The mystery of excess nitrogen, the key finding, revolves around unusually high levels of nitrogen detected in a distant galaxy, GS 3073. While elevated nitrogen levels aren't uncommon in early galaxies, the quantities found in GS 3073 are exceptionally high, exceeding what current models of stellar evolution can easily explain. This excess is the primary clue pointing towards the presence of population III stars, a theorized class of primordial stars that could have grown to immense sizes. These population III stars are hypothesized to form in the early universe when matter was almost entirely hydrogen and helium. Simulations suggest they could accumulate far more nitrogen than typical stars. The data from JWST indicate that just a handful of these supermassive population III stars could account for the observed nitrogen abundance in GS 3073. Why this matters? Challenging stellar limits. The discovery is significant because existing astrophysical models predict a maximum stellar mass limit of around 120 times the mass of the Sun. If these supermassive stars genuinely exist, it means that our understanding of how stars evolve and how galaxies mature is incomplete. The presence of such massive stars also raises questions about the formation of supermassive black holes, which appear in the early universe far sooner than expected. If these stars existed, they would have collapsed into black holes far more rapidly than previously thought, potentially explaining the early emergence of galactic centers with enormous masses. Debate and next steps. Not all researchers are convinced. Some argue that the chemical environment of GS 3073 is too mature for these primordial stars to have formed there. Population III stars are expected in pristine, nearly metal-free environments, while GS 3073 shows evidence of heavier elements. However, as John Regan of Maynooth University points out, the early universe was full of weird, exotic galaxies. Confirming the existence of these colossal stars will be difficult. Astronomers need more definitive chemical signatures or direct observations to rule out alternative explanations. The search continues, but the current evidence is the strongest yet for these long-hypothesized giants. Strengthening the argument for their existence is flat-out hard, but this signature is very strong. John Regan, Maynooth University.